So first of all, a very brief self-introduction. So I'm James Carlyle, and I started working on Corda with, as Mike says, a number of other people. I was really a bit player in the grand scheme of things almost 2 years ago, and I lead the engineering team.
Cool. Thanks, James. My name's Roger Willis, and I lead up the developer relations team at R3. So I've been here for about a year, and my job's really to be the lead advocate and evangelist. I'm not sure I like that word so much, but the lead advocate for Corda developers in the community. So it's really my job to help you guys that are building Corda apps be as successful as you possibly can.
So we're going to introduce Corda 1.0 and what that includes. But first of all, I'd like to say that it's fantastic to see so many people here. For us, today is about Corda. It's not about R3. So R3 is obviously providing financial support, but what we're really trying to do is grow a Corda community, because we know that communities matter in terms of the long-term adoption of any distributed ledger platform. So it's fantastic to see everyone here. We love our community, and we will do anything for the community. So take us to task on that. Be gentle, though. Okay. But as Roger said, we're trying to focus on building a community because we know that adoption of distributed ledger platforms is going to take time, and it's a risky endeavor, and distributed ledger platforms will find themselves embedded at the heart of business applications. And therefore, they're a long-term bet for any organization that's implementing them. And therefore, it's really important that a community surrounds them, and of course, that they're open source. Okay, Corda 1.0, what does it mean? Well, as I think Richard touched on earlier, what it means is that we're stabilizing the core API. And the implication of that for developers is not that you never need to recompile your application again, but that you can use core APIs and you don't need to rework your application as we go forwards. And this is incredibly important for us because we know that lots and lots of people are starting to build applications on top of Corda. We want to save them pain. We're going to cover some of the core features of Corda in this talk. But before we really get started, could I have a show of hands for how many people are already developing on Corda or know something about it? Great. Okay, so probably about half or 40%. So we'll tune our content to suit as far as we can. And finally, before we go, I want to re-emphasize that we've got a number of key developers here in the room. They're wearing red shirts. So we've got Kat, for example, who's been working a lot on serialization, Costas on security. We've got Jose, who's doing a lot of work on persistence. And Andreas, I believe, is with us. He's done a lot of work on our ordering service or our notary service. So if we don't go into enough detail for you, feel free to talk to those people if you've got more specific questions. Also, if you have any questions that we haven't covered and they're very detailed, come and find us and we will introduce you to the corresponding lead developers within the team. Okay, so Corda is very different from other distributed ledger applications. And the reason is because it's different by design. It's different because the requirements we started from, I think, are different than the requirement set that drove other ledgers. We think this is a good thing. We're happy to be driven by requirements, and we're happy that the design, while it is different, it has been shaped by those requirements. And we can link every one of the design features we have back to a set of requirements. And we'd be happy to talk about that in more detail if you have questions. But for today's talk, we want to focus on 5 areas. So first of all, how Corda is unique and how it's different. Secondly, how it handles complexity, the complexity that we find in the real world. Then next, how Corda supports the concept of fungible or transferable and mixable assets, such as cash. So cash is obviously an incredibly important concept for business. It's about payments, it's about money, and it makes many other business processes go round. We want to talk about how Corda integrates with existing technology, and then finally we want to talk about our developer experience. So with that, I'm going to hand over to Roger to talk about the uniqueness of Corda.
Okay, thank you very much, James. So what I'm going to talk about now is just a couple of high-level features in Corda that make it unique, make it different to some of the other platforms out there. So a lot of the other platforms out there are all actually approximately based upon the same design. They attempt to replicate or simulate a single-threaded global computer where anyone could start new programs or send commands to existing programs that update the state of the ledger. And this design is not really used by the other platforms because it's objectively considered the best design. It's used because the conventional wisdom at the time thought that this design, whilst it was created for a different purpose, could easily be ported to an enterprise environment where privacy becomes a primary concern. However, in contrast, as James mentioned and Richard mentioned in the first talk, at R3 with Corda, we started with a completely blank canvas. I mean, Mike started with a blank Git repository, started with a couple of unit tests, and you can actually go back in the Git log and see exactly where it all started. We didn't fork any other code base. We started from the very beginning. And some decisions we made at the time, some people thought, well, that's a bit odd. Why aren't they doing what everyone else is doing? But I think as time progresses, it's becoming clearer and clearer that the founding engineering team at R3 made some of the right architectural decisions. And as such, you know, we're seeing a lot more developers that began their journey on a different platform actually migrate and move over to Corda, and we're increasingly seeing that going forward. So let's just move on and talk about some of the characteristics of Corda. And you know, if you look at this slide, it's fair to say that Corda is kind of more similar to Bitcoin than you might think. I mean, the building blocks that make up the current state of the ledger are actually very similar to the unspent transaction outputs in Corda. In Bitcoin. However, in Corda, we call them state objects, and they can represent literally anything from cash, that we'll talk about a bit later, and Dave Hudson's going to talk about later on this afternoon, to healthcare records. Next, immutability. So in Corda, transactions are digitally signed, and they're chained together by including the hash of the previous transactions. So this maintains the immutability of an asset or an agreement, as well as its chain of provenance. Next, consensus. Corda allows potentially distrusting parties to enter into consensus about agreements that pertain to a transference of asset or an agreement or some kind of generic shared fact. Next, validity. So Corda mandates that only valid transactions can get committed to the ledger. And validity is determined by the contract code, which is referenced by each state object contained on the ledger. And these contracts encapsulate all the rules for what constitutes a valid transaction. And this is shared by all the parties on the ledger. Lastly, we got uniqueness. So with Corda, we have notary clusters which prevent double spends of state objects. And we can consider these notaries really as consensus as a service, right? They can operate in a multitude of different ways. They can be a singleton machine, they could be a raft cluster or a BFT cluster. And many can operate in parallel on the same network. So it's definitely not a one-size-fits-all approach to consensus with Corda. So next. Uniquely, though, with Corda, we feel we've solved a lot of the key challenges that the blockchains, public blockchains, didn't solve for the enterprise. And the main one here is privacy. So with Corda, data is shared on a point-to-point basis. This is in contrast to a lot of other systems that are broadcast. So Corda is a point-to-point system, and this is fundamentally different. Data is shared on a need-to-know basis only. So data is shared at the deal level. So we don't group unrelated transactions into blocks. We don't do that at all. We only share transaction data that is required for each counterparty. So data moves around the network on a need-to-know basis. Next, with privacy, we've implemented confidential identities. So this is a feature in Corda version 1. So you will know the identity, of course, of the counterparty that you are transacting with. However, when you resolve those back chains of provenance, all of the identity information would be scrubbed out, right? So all of those transactions are anonymous. And this is a feature that we've added to the platform and will be in Corda version 1. And lastly, you all listened to the previous talk about STX, and I guess using Intel secure hardware allows us to verify chains of provenance without actually needing to see the data itself. So with all of these kind of privacy mechanisms, it's fair to say that we believe Corda has probably one of the best privacy stories out there. Okay, thank you very much. So James is going to talk about complexity.
So I've just flown back this morning from Singapore, and what I was doing out there was looking at a piece of work that the Monetary Authority of Singapore is doing with a number of different teams. And they're modeling highly complex real-time gross settlement and liquidity settlement and netting. And I highlight that as an example of complexity. So I think when we look at distributed ledger platforms, we often go in and we look at very simple examples, and they hide the fact that when we get into real business, we can expect to see complexity that's 10 or 100 times greater. So Corda manages, it's designed to handle complexity. And interestingly, it doesn't just handle updates to the ledger, but it also handles the conversations between parties that are necessary to achieve consensus before the update to the ledger is made. So we know in real world business that before we want to update the ledger that represents agreements between parties, that there has to be a complex dance between these parties. For example, they might need to match trades, or they might need to check master agreements between each other, or they may need to inform regulators. And in many cases, humans are involved in approval steps as well. And for these operations, in some cases, approvals can take too long. So it's necessary for the process to be restarted. For example, if we're dealing with foreign exchange, FX trade, FX rates, of course, are always moving. And if they move out of band, then it may be necessary to restart the entire process. One thing that is different about Corda is that it allows consensus to be achieved between parties to a deal before writing to the ledger. So I think this is in contrast with other platforms like Ethereum, where effectively smart contract controls the code, and the code controls the data of the smart contract. And parties are making unilateral entries via the code to update the data. But they're not at that point achieving consensus with each other. They're only achieving consensus according to the rules of the smart contract. So as we'll see shortly, Corda allows for parties to reach consensus as part of a conversation and then agree to update the ledger separately. So Corda 1.0 ships with something called the flow framework. And the intent of the flow framework is to make these conversations easier and make it easier to achieve consensus. And we know that without this, it's necessary to write lots and lots of tedious but important code to check messages, to send them, to undertake checkpointing and so on, so that as the consensus steps are achieved, it's possible to write that away and restart if necessary. It's awkward programming and it's prone to mistakes. And I think Mike Kern spent a lot of time dealing with these issues when he was writing Bitcoin code and some of the other projects that he built on top of Bitcoin. And of course, these flows will only increase in complexity. And it's going to be harder and harder to get this right. And we think of a lot of banking IT as effectively simply doing workflow. I think there's workflow not just in banking IT, but also in the IT of many, many industries. So what we want to do is take a look at an example. So as you can see on this depiction of a network, a Corda network, we've got a couple of counterparties, Alice and Bob, and there's a uniqueness service or a notary that's also going to participate. And we're going to step through a sequence. This is the sequence of steps in the flow. So what we begin with Alice creating a transaction, which is a proposal to update the ledger. And Alice is obviously happy with that because she created it, so she goes ahead and signs it. And then the flow framework in Corda automatically routes that message across to Bob. Bob is identified as the counterpart. Bob inspects this message, inspects the proposal, verifies it himself, wants to check that it's okay, and if he agrees, he signs it and forwards it on to the ordering service. The ordering service is a key adjudicator in all of this. And the ordering service, its prime function is to make sure that the ledger can't have two alternate futures. Because if the ledger could have two alternate futures, then we couldn't deliver the promise that I know that what I see is what you see, because you could be seeing a different alternate future to the one I see. So the notary signs, returns the message back to Bob. At this point, the message is constituted with a transaction that has been signed by Alice, by Bob, and by the uniqueness service or notary. So Bob now considers this final and commits the transaction. So the data is stored in his copy of the database. And Bob sends the transaction, fully signed transaction, to Alice, and Alice does the same. She commits it as well. And now both Alice and Bob have updated their ledgers with a proposal that Alice originated but has been fully signed by all of the parties involved. And they've achieved two things. They've achieved correctness validation because Alice and Bob independently verified the update to the ledger. And they've also achieved a uniqueness validation, which is something that the notary provided. The final point is that, and this is, I guess, level one of the Corda privacy story, that nodes that were not involved in the transaction have no sight of it. They don't know the transaction even existed. And they certainly don't have a copy of the data. A key point that Corda is deterministic in terms of where the data resides, which is an important point for lots of jurisdictions. And the flow framework does all of this so that developers don't need to do it. And just to go into that in a little bit more detail, so the flow framework takes care of sending messages to the correct node and not to others, checking legal identities of the parties involved, retrying messages if nodes are offline for any reason, or buffering messages if nodes are slow in processing them, because this processing is asynchronous between these parties. It also handles the encryption of conversations and message passing. And it checkpoints progress for restarts. So at any point, if one of these nodes goes offline, or in fact, if one of these nodes has some kind of technical outage, the flow progress to that point in time has been persisted. The flow framework persists data to the database, for example, if the flow pauses, which means that it can be restarted in future. We don't have to go all the way back to the beginning. The flow framework also is responsible for helping developers connect to internal systems. And it also provides for permissioning. So within the 1.0 API, there's a concept, a class called flow logic, and it has a check flow permission method on it that allows very fine-grained control of permissioning for initializing particular flow steps. And the final point, which is hidden, but it's perhaps the most important, at least from my perspective, is that it makes writing Corda flows very easy to test. So everything we do in Corda is test-driven, but we're also very focused on building domain-specific languages to make it very easy to write unit tests for the applications on top of Corda. So not just smart contracts and the way they work and the rules embedded in them, but also the way that we update the ledger through this flow concept. Another point to note is that these flows are components. And what we're aiming for with them is to allow developers to use composition. So flows build on top of each other. And as an example, we can have a flow that represents a legal document management between parties, which might check, for example, that both sides have consensus on a master agreement. And then that flow can be used as a subflow within another application. So, for example, there might be a Corda application that handles interest rate swaps. It might need to use composition like that. Or, for example, payments. We have payments as a flow. They might reuse a subflow for foreign exchange conversion, and that might in turn embed a subflow for obtaining an exchange rate from an oracle. We already ship with a number of base flows, reusable components, for example, for asset swap, for payments, for collecting signatures, and also for transaction ordering with the notary service that we saw earlier. And we'll continue to add these over time. Now, Roger's going to talk about assets.
Okay, thank you, James. So, as James mentioned, one of the most important use cases for blockchain platforms is supporting fungible assets. And we like to think that Corda is very much engineered for dealing with these fungible assets. So just to begin, some of the other platforms are, as I mentioned, they're based on this replicated virtual machine model, which I described earlier as this single-threaded global computer where anyone can start new programs and send commands to existing programs, which updates the state of the ledger. So to deal with a program that supports cache in this system, you have to write a program or a contract that looks something like this, right? We can see at the very top there is a mapping, and this is a mapping of who owns what coins. It's pretty simple. Then we have a method to mint new coins or create new coins. And lastly, we have a method to transfer coins. This is really just, I guess, rudimentary single entry bookkeeping. But it works. It kind of works, right? And in a public space, this is perfectly fine, okay? You can use this contract to keep track of who owns what coins. However, if we try and take this and put it into the enterprise, where privacy is of utmost importance, then it starts falling apart. Now, some of the solutions that we've seen in the space for this problem are something called channels. So you can create subchannels, which are kind of just mini blockchains. And you can have as many participants as you want in these channels. However, you must specify them up front, okay? So imagine Alice and Bob share a channel, and they can transact within that channel. There will invariably be lots of different types of things in that channel. There could be different deals, trade records, I don't know, the asset transfers, etc. However, what we noted when we actually considered this approach for building Corda, we noted that there's not really any easy way to extract data from these channels with history and provenance. And we actually note that it's really an all or nothing proposal when you consider a channel. And you guys have probably seen this before. It's taken inspiration from Richard Gendel-Brown's blog post, where he noted that what does Slack know about enterprise blockchain systems? And it's a very good analogy, actually. So the other day, I wanted to invite somebody to this channel, Ubin Design, and the desktop version of Slack came up with this message. And it's quite interesting, because if I want to invite somebody new to the channel, then they get to see all of the history of the channel, as well as all of the future messages in that channel. However, if I say no, then I archive the channel and I move everybody into a new channel. And the new participant doesn't get to see the archive; they just get to see the incrementally new messages. Now, this is quite a good analogy, because it kind of illustrates exactly how channels work in the blockchain space. So now, if we take this and we imagine Alice and Bob with their channel, there's some cash in this channel, and now Bob wants to take this cash and send it to Charlie. Well, how would Bob actually do it? Well, if Bob invites if Bob invites Charlie to the channel, then he sees all the transactions between Alice and Bob. This isn't really what we want. We can't easily extract one piece of information from the channel because it's all ordered. It's all in this mini blockchain, right? We can't just take one piece out because it will be without provenance. Bob can't simply just go to Charlie and say, hey, just trust me, okay? This is the asset. You don't need to see the chain of provenance, because that defeats the whole point of using a blockchain or a distributed ledger platform in the first place, where it's around parties that don't necessarily trust each other reaching consensus. Maybe another option would be to ask Ivan, the issuer of the cash, to say, will you redeem this asset in my channel and then reissue it in the new channel between Charlie and Bob. But then this just introduces a central party, and this is the paradigm that we're trying to get away from. Alternatively, what maybe Bob, Alice, and Charlie could do is create a new channel for each transaction. But this kind of gets awkward, because I think you need something like n multiplied by m plus 1 over 2 channels multiplied by an average of m transactions on between each pair of bilateral nodes. So you end up with a lot of channels, okay? And it doesn't necessarily scale very well. So what is the solution? What is the solution? Do we have a solution for this? Well, indeed we do. With Corda, the goal is to have a single ledger that is for everything and everyone. And that is indeed what we've built. So with Corda, everyone that shares the same network shares the same Corda ledger. But of course, the need to prove provenance never goes away. But what we do is we do our absolute best to make sure that the data that's needed to satisfy the recipient is the de minimis amount of data. So with Corda, the history of the ledger or the provenance of an asset or an agreement is only sent to you if you become authorized to see it. So you can think of the ledger as shrouded by some dark fog or dark mist, and you can't see the majority of it. However, when you are authorized to see it, you see only what you are supposed to. So let's say in this transaction between Alice and Bob, or Bob and Charlie, and Bob sending this 8 GBP and 2 GBP to Charlie. Charlie wants to ascertain the provenance. Well, then Bob also sends Charlie the previous transactions. And Charlie only gets to see the information that is required for him to ascertain provenance of that £8 and £2. And this is what we do with Corda. This model is conceptually a little harder to grasp than the replicated virtual machine model, but it means that as long as you're on the same network, you never see any more data than you have to. This data travels around the network on a need-to-know basis only. And coupled with Intel SGX, that Mike and Simon were talking about, well, we can actually use that technology to encrypt these back chains of custody in such a way that the computer checks it for you, but the actual underlying data is not revealed to you. So that's how we deal with fungible assets on Corda.
So we're running slightly short of time. We'll just like to cover a couple more points. The first is that Corda integrates with what already exists. So I guess a number of us in R3 have come from Google and institutions like that. A number have come from banks. We're very well aware of the massive investments that these organizations have made in existing infrastructure. And we know that it takes a lot of money and a lot of time, lead time, and to change infrastructure and change processes. And we decided to focus Corda wherever possible on using existing infrastructure and existing technologies. You know, we weren't interested in just recreating something for the sake of it. We know that, for example, banks have made huge investments in technologies such as Java, enterprise databases, and message queues. And they have a great ability to manage those systems because they understand how to. They've developed management processes over a couple of decades. And they, of course, have huge numbers of developers and an amazing talent pool within their organizations that we wanted to reach out to and appeal to. Just a couple of examples of these. So for Java, of course, Corda is based on JVM. Last year, we did a lot of work with a library called OpenGamma, which is an initial margining library. And we showed how easy it is to use existing libraries directly in Corda contract code. SQL, so Jose is going to be talking a lot more about this afternoon. But suffice to say, of course, big organizations know how to use SQL. And Corda supports ideas like being able to query the ledger directly using existing tools and import the ledger into an enterprise warehouse, a data warehouse. So with the final point, we're going to cover developer productivity.
Thank you, James. So I'll be super quick because I realize we're running out of time. But I think this is a really, really important point to note. You know, I speak to a lot of Corda developers, and I believe the overwhelming message that I receive from them is that it's a friendly and enjoyable platform to build upon. And I think that's the reason why that is threefold. So firstly, our technology choices. We use technology. I mean, we just had a slide with SQL databases, message queues, and Java on. We use technology that a lot of developers are already familiar with. I mean, just take Java for instance. I was at one meetup, and some chap piped up and said, "Well, I develop for a platform, and there's 1 million people that know this language." And aside from the fact that whether 1 million people do actually know that smart contract language or not. Someone else piped up and said, well, you know, Corda's based on the JVM. There are actually 9 million developers that know Java, right? That's incredible. So there's a huge cohort of developers that can begin building on Corda with minimal training, and we see that. We trained over 500 Corda developers now, and they're ready to start building on the platform. In terms of tooling, so Mike did a great job in including the Flow framework, the Flow testing mock network with the platform. And this is a great utility that allows you to quickly prototype a flow and then build it using in-memory nodes. I mean, I can't stress how useful that has been for me as a Corda app developer in the past. And I'd heartily recommend those of you that are developing on Corda to give it a try if you haven't already. As James has mentioned, the Flow framework in a great amount of detail. So the Flow framework handles a lot of the stuff for you. So like serialization, fault tolerance, networking, you don't have to do this. So you can concentrate on the business logic of your application. And lastly, flows can be built, and they can be called as subflows. So you can have a flow library of procedures, of functions that do a lot of the work for you. So again, so you don't have to do it. But lastly, and most importantly, I think that community enables a productive developer experience on Corda. Like, we put a great deal of time into helping Corda developers succeed. And that's why we have a dedicated developer relations team that acts as advocates for all you guys. It's our job to help and support you so you can be as successful as you possibly can. We pride ourselves on the documentation and sample code that we deliver, and it's been a hard job, right? Because Corda's been moving from milestone to milestone very quickly, and it's been difficult to keep up. But of course, we're here to support you and just make you guys as successful as possible. I think on that note, because time's up, we've got probably about, can't quite see the clock, 2 or 3 minutes for questions.
I think we can still do 5 minutes, do a couple questions. So we've got the blue box. If we want to, first hand up gets the first question. Does anybody have questions? Oh, right here. And then there.
Thanks. Hey, you mentioned that you are also doing domain-specific languages in the context of writing flows. Could you expand a little bit on that? Because I haven't seen that so far.
Domain-specific languages.
Yes. So we have a couple of examples in the code where we are using domain-specific languages to be able to define unit tests for writing for contracts and for testing flows as well. And that means the languages are very, very simple. You know, there are lots and lots of examples as well within the code base. So you can take a look at that. But you know, clearly, writing unit tests is absolutely foundational. And you know, I struggled for a long time personally with Ethereum before some unit test frameworks came along. It was all hit and miss and trial and error. We want to avoid all of that and get people testing as they go.
So there's 2 DSL frameworks I can think of. There's the Ledger DSL and there's the driver DSL as well. Then also actually in the experimental module for Corda, there's another DSL, smart contracts DSL as well. So do take a look at it.
But all in the context of the unit tests you're saying, right? The driver DSL, that's for me to set up a test network.
The third one that Roger mentioned is actually a domain-specific language for writing business contracts. So I guess what we're trying to do is achieve a balance where people developers can write contracts according to business requirements. But in some cases, we want to make those contract rules as readable as possible, and that's where some of these domain-specific languages come in, because it's possible for a business user to look at them and rationalize what's going on.
And I think we had a second question, was a couple rows back. You can actually throw it.
Yep, okay. So my question is around how the value transfer is enforced in the smart contracts, because you had a slide up there saying some pounds were transferring around, but those pounds are in a bank somewhere. What's actually tying the consensus of the state to the bank? As opposed to a cryptocurrency where there's a globally agreed value based on something like Bitcoin or Ether. So how is that happening?
So that's a really good question. I think we've got a longer conversation about cash and how we handle it this afternoon. But very briefly, cash, we model cash as a claim against a bank, whether it's a commercial bank that you've deposited your money at, or whether it's a central bank. And what we're doing when we think about payments is changing ownership of that claim, so that where I can have a claim against a bank and I assign the claim to someone else, then they have the claim against that bank.
Well, I might save any other questions for later. So.
Yeah.
Excellent. So I think we'll do a last question just to stay on schedule.
Hi, so in a world where lots of industries or enterprise customers are on the platform, how are release weekends or release management processes going to play a part of this? Are we looking at monolithic multi-industry releases, or are we looking at some coordinated fashion or coordinated way of managing release weekends?
That's another great question. So release management, I guess it happens at two levels. It happens at the level of the platform itself, and we have the concept of version of the platform. And of course, going forwards, we want to ensure that different clients can run different versions of the platform, but the platform will take care of checking that the version that the other side is using is compatible. But of course, we also have the issue of versioning and release management for contract code, which sits inside applications that run on top of the platform. And we know that all code has bugs. We completely expect this in the smart contracts themselves. So we thought a lot about how to evolve smart contract code. And one of the features of Corda is, and we can cover this more offline, that the code that governs the evolution of the ledger, of states on the ledger, can itself be upgraded through a special transaction, as long as the owners of that agreement agree to that upgrade. So it's actually really easy to move agreements between parties to new code that governs them.
Excellent.
Okay.
Thanks, James and Roger.